Hey friends, welcome back to Nexus Innovate. Today we're not just talking about the future, we're diving straight into it. A world where computers don't just crunch numbers, they think almost like the universe itself. Yep, I'm talking about quantum computers. So, what are they really? How do they work? And why are the world's biggest companies racing to build one? Let's find out. Inside a quantum computer, here's your first surprise. It doesn't look like a laptop or a gaming rig. Instead, picture a giant golden chandelier hanging in layers, or sometimes just a massive fridge. Why so weird? Because qubits, the heart of the system, are super fragile. They only survive in conditions that are almost impossible in nature. Temperatures colder than outer space, absolute silence and vacuum, zero outside noise or vibration. What's a qubit? Pauses. Think of flipping a coin. While it's spinning, it's both heads and tails at the same time. That's superposition. Now imagine tossing two coins in different countries, and somehow they always land the same way. That's entanglement. Different labs use different tricks to make qubits: superconducting loops, trapped ions, atoms in laser grids, photons, even diamonds with tiny defects. But here's the problem. Qubits are delicate. To get a single, stable, logical qubit, you might need thousands of physical ones. Why are they faster? Classic computers solve problems step by step. Quantum computers, they test millions of possibilities at once. It's like being lost in a maze. A regular computer explores corridor after corridor. A quantum computer scans every path instantly and just shows you the shortest way out. Where will they change everything? Medicine. Simulating molecules exactly the way nature does. Faster cures for cancer, Alzheimer's and rare diseases. Optimization. Food delivery, flight schedules, supply chains, city traffic, billions of routes solved in minutes. Finance. Market analysis in seconds instead of hours, smarter predictions, but also bigger risks. AI. Neural networks that take months to train today could be trained in days. Think AI on turbo mode. Cybersecurity. Bad news. Today's codes could be cracked in minutes. Good news. Quantum cryptography already exists, and it's basically unbreakable. The quantum race of 2025. So, who's leading right now? IBM with its Eagle processor, 127 qubits, and Condor coming soon with over 1,000. Google's Willow chip with impressively low error rates. IonQ's Forte Enterprise, small but insanely precise. Quantinuum hitting 99.9% accuracy. D-Wave with 4,400 plus qubits focused on optimization. Atom computing smashing records with 1,180 atomic qubits. Microsoft betting on topological qubits, maybe the most stable of all. And the money? Over $10 billion already invested. The market itself is already worth more than $1 billion. Inside a quantum computer, it's 150 times colder than space. A qubit is literally Schrödinger's cat, alive and dead at once. Quantum teleportation, it's real for particle states, not people. Birds may use quantum entanglement to navigate across continents. plants might rely on quantum effects for photosynthesis. Helium-3 for cooling costs 10,000 times more than gold. And fun fact, the very first quantum algorithm was invented way back in 1994, before most of today's smartphones even existed. The bottom line. Quantum computers won't replace your laptop, but where classical computers struggle, they'll unlock entirely new worlds: medicine, transportation, finance, AI, security. Within the next 5 to 10 years, everything could change. So let me ask you, what do you think quantum computers will change first? Medicine, AI, cybersecurity? Drop your thoughts in the comments, and don't forget to like and subscribe if you want more deep dives into the future. See you next time on Nexus Innovate.